Okay, so this is the demonstration setup for Explore 1 from Weathering and Erosion. So what we have here is a paint pan that is doing double duty as a stream table. If you've ever played with a real one, a real stream table, they're actually much, much longer, but this is going to suffice for what we want to do today. So what we want to look at is how wind erosion and water-based erosion compare with each other. So this is not going to be weathering so much. These things are already broken down into small pieces, but we're looking at how the material moves around when water and wind acts on it. So what we have is sand with different textured stuff in it. So you can kind of see, we smoothed it all out. Up here is a continent. Down here is an ocean basin. So we're first going to do some wind, and with the wind, we're going to use a straw. So you get to watch me be the wind blowing material around. So let's see how we do. Okay, so we made kind of a mess, as you can see, but material definitely moves when the wind blows on it. You're going to need to pause the video and you're going to draw a quick sketch of what you observed, just illustrating what you saw. So pause the video and you can come back in just a minute when you've done that. Okay, so hopefully you're back now, having drawn your diagram of what you observed with the wind. Now we're going to do some water-based erosion, and we're going to do two different river channels. I have moved everything back up here, so it looks all nice and smooth, relatively smooth again, but we are going to go ahead and give our river a channel to work with, so we're going to just kind of make a straight little gully here. Straighten it out on either side. Just kind of gives it a place to start. Okay. And what I have next to me here, I have I have a measuring cup here that has about 900 milliliters of water in it. So you can, if you have a paint pan at home, this is an easy thing to do. This is just sand, different types, some lighter stuff on top. All right, so here's our water, and I'm just going to start it really slowly right here. Let it pour down. Stream tables are a lot of fun to play with. It's even more fun if you can get a hold of like little farm animals and stuff and try to build dams and things. You can really get a good sense of the way material moves downstream. Okay. All right. So as you can see, we've moved quite a bit of material around. This is now completely empty and has kind of hollowed out, almost like an hourglass-shaped valley here. And we've moved a lot of sediment downstream. And notice how once it hits this water, it all falls out when it hits the ocean. And then down here, there's nothing. So this is a pretty good analog of what happens with a river. Remember when we talked about delta formation, we talked about the fact that the water speed is carrying a lot of sediment with it, but as soon as it hits kind of a body of water like this, it will slow down and all of the sand that it was carrying will fall out. So this is how a delta forms. Okay, so take a minute, go ahead and pause the video again. You're going to do a drawing of what you saw here with the straight course, and I'm going to reset this up with the sand already a little damp, and we're going to do it again, but we're going to use a curved river. Okay, so go ahead and draw and come back as soon as you're done. Okay, hopefully you're back, having drawn your sketch of the straight river. So now we're going to draw a channel in the sand that is curved. So this is going to be more like an older river would be, where it has what we call meanders. So I'm just going to use my finger here to make kind of an early little channel for the river. Smash this out a little bit. Okay, so that goes all the way down to the pan underneath. So it's very, very deep channel. Okay, and now once again, we're going to pour in a bunch of water and have you watch what happens. Okay. All right, keep your eye on the sand as best you can. I'm try to move this just a little bit closer so you can see what happens. I'm going to start pouring right here. Okay. So hopefully you've noticed that was quite a bit different. All right. Notice that you now can almost not see at all where the original meandering path was. Eventually it just crashes right through it and starts making a straight path again. Okay, so go ahead and pause again and draw that. I'm going to take a little bit of this water out, reset up my beach, and then we have one last little demo. Okay, now it's time for our very last demonstration. In this case, you've noticed I've reassembled my continent. So now we have a nice beach here, and we have some water here in the ocean. So what we're going to look at here is wind erosion through wave action. So it's a combination of air and water. So what I'm going to do is I have my handy straw, and I'm going to blow some waves up on the ocean. From the ocean up onto the beach, so you can kind of observe what happens there. Right? Okay. All right, so hopefully you can kind of see how when they splash up there, it changes the shoreline just a little bit each time. Okay, so go ahead and sketch. This would be part 2. Um, this has us doing it with an index card, but the index cards kind of don't make enough of an action to show on the camera. So when you're done with those 3, then you'll have a claim evidence reasoning, and you're to write a scientific explanation that describes how water and wind cause weathering and erosion and shape Earth's surface. So your claim is going to, based on what we saw here, what effect do you think that water and wind have on shaping Earth's surface? Your evidence should come from what we observed here. So you need to list in your evidence what you actually saw. Okay, it should not just be, don't give me definitions of erosion here. Don't give me definitions of weathering. Don't do that. Just say, I observed the water did this. I observed the air, the wind did that. That's all you got to say. And then in your reasoning, that's where you explain how water erosion and weathering can work, etc. Same with wind. Okay, good luck.